integration by substitution, also known as U substitution. So objectives. By the end of this lesson, you should be able to recognize when to use U substitution, how to find the U in the U substitution, and then how to finagle and actually do the integration by using U sub. Now, the thing about integration that's hard for a lot of people is the rules, right? When you do a derivative, when you try and take a derivative, there's lots of rules. There's a power rule, there's a product rule, there's a quotient rule, there's a chain rule. And when you integrate, there's a power rule, and there's not a product or quotient rule. There is a reverse chain rule of sorts, right? So it's not the same. Oh, I'm multiplying two things. I got to do the product rule. It doesn't work with integration. Generally, if it's not a power rule or a reverse chain rule, if it's more complicated like this, it's usually gonna be a U sub. That's how we can get around it. So if you're looking at something that's a little more complicated than normal, it's probably gonna be a U sub. Right, like this right here, example of a U sub. If instead I did this, now a U sub would actually work on that, but you can just do reverse chain rule. Right, it's once I add something like a square there, or like there's something inside, it's probably gonna be a U sub. Now, it's a lot more complicated. Reverse chain rule was simple, it's just like a chain rule, but instead of multiplying by derivative of the inside, you divide by derivative of the inside, and you integrate the outside. Reverse chain rule in U sub, requires a little more work. So first, we got to identify what the U is. Right, so that's the inside function most of the time. Not always. We'll talk about some fractions where it's kind of the numerator denominator. Most of the time, though, it's an inside function. So like if we're looking at this one, right, my U here would just be the inside function, which would be x squared. So next step, find the U taking the derivative of U. Okay, let's talk about what that means. So the whole idea, so right now we have U equals the inside function. So let's look what our function looks like. Right, my integral looks like this: 2x cosine U dx. That is a mess, right? We have u's, we have x's. I don't know what's going on. So the whole idea is I want to get rid of this dx and just make it a u, because they all have to be the same variable to take the integral of it. So next we gotta do is basically find what du is. And the way we do that is by taking the derivative of both sides. So like over here, we have u equals x squared. We're gonna take the derivative of both sides. Now, something you focus way more on AP Calc than we do in IB, but this little part you gotta trust me here. You take a derivative of this, we're gonna take a derivative with respect to x. So the derivative of u is 1. And then we took a derivative with respect to u over respect to x. So what does that mean? Well, we're taking the whole thing with respect to x. That's a different variable. So we'll put du over dx. Just trust me, basically, because again, we'll talk about this. You talk about this more in AP Calc. Derivative of u is going to be this, du over dx. And then over here, it's the normal derivative, 2x. Right? So this kind of like when we take, if you think about it, when we take y equals 3x, that's what's the derivative? Another notation was dy over dx. Same concept, right? So take the derivative of u. So normally it's dy dx, when we have a u there, so du over dx, and on this side, just take the derivative of 2x. So we have that. I don't need this part here anymore. So that's what the second step is. Find du. Get a du. Basically, step 1 is, right? Find your u. Step 2 is take a derivative of your u. So 1, find u. 2 is take the derivative of u. And then what's going to happen here, step 3 is, we want to put all that stuff back. So we want to get rid of that dx. So I'm going to say step 3 is solve for dx. Look, I don't want the dx. I want to replace it with the du. So over here, I'm going to solve for dx. So let's multiply both sides by dx. We're going to get this. Right, just multiply both sides by dx. Then again, I want to get dx by itself, so divide by that 2x there. So you get du over 2x equals dx. That's step 3, solve for dx. Why is that so important? We could plug it back into this now. So this equation is going to become this. Integrate 2x cosine u. That dx is going to be switched over with the du over dx. And then look what happens. The integral of cosine u du. And that you can integrate. So that's step 4. Actually integrate the thing. Go back to integral with respect to u. And then once you've done integrating this, like over here I have cosine u. Integral of that's going to be sine u plus c. Once you're done, don't forget to go back and put your u back in. So this would be sine of x squared plus c. But that's generally the steps. Step 1, find your u. So over here we find our u. Step 2, take a derivative of that u. So we have this, take a derivative of both sides. Derivative of u is du dx. It's like derivative of y is dy dx. Right, derivative of 2x is 2x. And then step 3 is solve for dx. You want to get dx by itself, so you have to multiply, do some mathematics. And then once you get dx by itself, you can plug it all back in into your equation. Hopefully stuff cancels, and then it's just a normal problem. Integrate it and plug your u back in. So those are kind of the 5 steps. And it's a little messy. We're going to do plenty of examples like this one right here. So our first example. All right, so the first thing we want to find out is what's our u. So to me, this right there. U equals x cubed. Now remember, the whole idea is I want to be able to plug it in, because right now if I look at it, you have this thing going on. And that's this mess. There's u's and x's. You don't want that. You want to be able to replace everything. So next step is take a derivative of both sides. So derivative of that to me du dx. And derivative of that's 3x squared. And right, just like when you take a derivative, we're taking with respect to x. That's a u there. So du with respect to x. So I have that. And the whole point of this now is I want to get dx by itself. So multiply both sides by dx. So I get du equals 3x squared dx. Get the dx by itself, divide by 3x squared. And once I have that, I could go back into my equation here and just plug it in, right? I'm plugging u in for here, and I'm plugging du over 3x squared in for dx. That's the whole idea. So we're going to get this 3x squared cosine u. And instead of dx there, I have all of this. So du over 3x squared. If you notice, these cancel. You just get the integral of cosine u du, which gets me negative sine u plus c. Now you plug your u back in, negative sine 3x squared plus c. And that's the general idea of how to do u sub. We're going to do a lot more though. But right, it's just those simple steps. Step 1, find your u. Generally it's the inside, not always, but generally it's the inside. Step 2, once you have your u, take a derivative of both sides. Once you do that, step 3 is get the dx by itself, right? So do some algebra, get the dx by itself. Step 4, plug it in. Then 5, integrate and solve, and then don't forget to plug your u back in. That's the general idea. Find your u, take a derivative, get du by itself, sorry. Or dx by itself, you get dx by itself, man. Anyway, next one, right? Same concept. Find our u. Stuff on the inside. So this is going to be u is equal x squared plus 3. Then we're going to take a derivative of both sides. Derivative of u, du over dx, because we're taking with respect to x. And over there it's going to be 2x, the 3 goes away. Now let's try to get the dx by itself. So multiply both sides by dx. If you're pro, you can always just skip to whatever that's supposed to be. Oof. I'm apparently not pro. Then divide by 2x. Like that, right? Again, picked my u, took a derivative of both sides. Derivative of u is du dx. That's normal derivative. Try to get the dx by itself, so I just multiply and divide. And I have this. Now the whole idea is now I could go plug everything back in. So I go back to my original problem. The integral. Oh, my integrals are so bad. Inside there is my u, right? My u is x squared, so that's my u to the 5th. And instead of dx there, I'm going to plug in du over 2x. Now in this case, not everything cancels out. Look what happens. The x's cancel. I'm still left with 2 on the bottom. Well, the easiest thing to do is pull it out. Remember that rule? You can pull out the constants. So you get something like this. So you always just pull out that constant. Now remember, the whole point of this is that, hey, they're all the same variable. I can just integrate this like normal. Integral of that, well, remember it's the power rule. Add 1 to the power, divide by a new power. So I'm going to get 1/2 times u to the 6 over 6 plus c. Don't forget the plus c. right? You can do a couple things. You can make it a little simpler. Also, don't forget to plug your u back in. Don't leave your answer with a u in it. It's a rookie mistake, right? So let's plug your stuff back in. X squared plus 3 to the 5th over 12 plus c. That's u sub. For a lot of people, this is the hardest type of integration because you gotta get the find your u. You gotta substitute, plug in, take a derivative. It's the whole process. But it's just that. Find your u. Take the derivative. Once you find your u, take the derivative both sides. Get dx by itself and then plug it in. It's just a process. So this is the next one. Now if I do this one, I get my u's gonna be the inside. So I'm just gonna do a little faster. U is 2x plus 3. Let's take the derivative both sides. Du equals 2 dx. Sorry, skip the step. Du over dx equals 2. And then multiply both sides. Divide by, get the dx by itself, divide by 2. I'm going this way, it's space. So that's my dx, right? Got dx by, I got my u, I found my dx. Plug it all in. So it's going to be the integral of sine. One day I'll draw a nice integration sign. One day. For dx, plug in du over 2. Again, if you want to make yourself better, you can pull out the 1/2. Nothing canceled, nothing needed to. And then you just integrate this. Integral sine is negative cosine. So it's be negative 1/2 cosine 2 cosine u plus c. Plug the u back in. Negative 1/2 cosine 2x plus 3 plus c. Right? Works. By the way, did you notice? On this one, I actually didn't need to do u sub. The term's linear. We just done reverse chain rule and got this, right? Oh, it's a linear term, so, right, integrate the outside, negative cosine, leave the inside alone, times by the derivative of the inside, divide by the derivative of the inside. Always do that, right? Divide by the derivative of the inside is 2, divide by 1/2 plus c. The exact same answer, right? If the inside is linear, you could just do the reverse chain rule. It's a lot faster. U sub still works though. Works, it's great, I love it. But when you integrate, if the inside is linear, you just do the reverse chain rule. When it's not linear, like this one, x squared can't do it. This one, even if it wasn't, there's something on the outside just to make it messy. You have to do u sub. See some more. Look at this one right here, right? Again, the inside is not going to be linear, so it has to be u sub. Can't do reverse chain rule. So look at this one right here. That inside, that's my u. U equals x squared plus 1. Take the derivative both sides, so du over dx, right, so derivative with respect to x, equals 2x. Just some basic mathematics. Divide by that. Right, and again, I have everything I need. I have my u and I have my dx. So two things you gotta find. Plug it all in. So I'm gonna have x e to the u, and then instead of dx, I'm gonna have all of this. Du over 2x. X's cancel. Again, if you want, you can pull the 1/2 out. This makes life a little easier. I thought that was the right one. This one, not so much. Right, and then we just integrate this. Integration e to the u is e to the u plus c. Last thing, plug your u back in. 1/2 e to the x squared plus 1 plus c. Hope it's getting a little easier. Right, so it's a process. Find your u, take the derivative, find your dx, plug it all in, then integrate like normal. That's all it is. Find your u, find your dx, plug it all in, integrate like normal. The next one though is a little tougher. Right, so I have tan here. Now if you notice, in our formula sheet, we have sine inverse and cosine. They don't give you tan inverse, because they want you to be able to do it yourself. So if they ever ask you this, expect you to know. So first step with this is rewrite tan. Tan is sine over cosine. So this is a u sub. Like I said before, it's not always inside. In this case, it's a fraction. Now the trick with the fraction one is that you want stuff to cancel out. So if you're not sure, honestly, just pick one in and see if it works. If it doesn't, try the other one. The general idea is you want to cancel stuff out, right? So you're going to find something with du over, like how we've been doing. If you notice the part where you use always a fraction on the bottom. I was trying to find good ones. But over here, like the x is canceled, right? There's an x on the bottom from everything. 3x squared canceled. So generally we're going to want something to cancel the top. So I'm going to let the u be the bottom. That one, when I plug my thing back in, hopefully it cancels with the sign. Again, if you're not sure, just pick one. Try sign and see if it works. But the trick is going to be, let it be the bottom one. So my u is going to be cosine x. I'm going to take the derivative both sides. So du over dx, so the derivative u is that, equals the derivative cosine is negative sine x. Again, just like always, try to get dx by itself. So do a little algebra. Divide by that. So then with this, I have everything in, I could plug it in for there, and I could plug it in for here. Right? So now my equation doesn't look like this. The integral of sine x over u times, remember dx is switched with all this, du over negative sine x. These cancel. There's still a negative on the bottom, so I'm pull that out. Negative 1. Integral of 1 over u du. Don't forget, right, there's a 1 on top. It canceled out. Okay, so remember what that integral is? Natural log. So negative 1 natural log of u plus c. The last step, plug your u back in. So in this case, my u was cosine. So negative natural log of cosine x plus c. That's an ugly integration, but wasn't too bad to do though. Right? It's always the same process. Find your u, take the derivative, find your dx. Right? That's all it is. Plug it in, integrate like normal. Let's do a couple more. Look at this one. Now, so hopefully it's easy to see what the u is, right? It's going to be this right there. U is going to be 5x plus 1. Let's take the derivative. Du over dx equals 5. Do some algebra. Multiply by dx. Du over 5 equals dx. Now, if you look at this one, when I plug it back in, look what's going to happen. So integral x, let's rewrite that to the 1/2 power. So this is going to be u to the 1/2 du over 5. Notice they're still not all the same. I didn't have an x cancel out. So this type of problems you're actually not going to see in IB. You would see in AP calculus, and there actually is a way to solve that. It involves going back to here and figuring out what x is. X would equal minus 1 divided by 5, u minus 1 over 5. And you plug that in here, and then you do some algebra to simplify it, and then you just integrate it like normal. But you won't see this in IB. If IB gives you the u sub problem, they're going to give you one where it cancels out, and it works like the one we've been doing. So you don't have to worry about one like that. But it is possible to solve it. It's a little annoying with algebra. So last couple, and then we can be done. Last few, I should say. Let's look at this one. So here, which one's going to be my u? Well, again, you want the one at the inside, so you can tell this is on the inside, but also has a higher power. Why is that important? Because remember, the whole idea is we want stuff to cancel out. So this is going to be, if you take the derivative of this one, you're actually going to get this, so we'll be able to cancel out. So there's my u. U is going to equal x squared plus 3x. Right, so after we do that, next step, take the derivative of both sides, du over dx. Derivative that's du over dx. That side's 2x plus 3. Try to get dx by itself, right? So multiply both sides by dx. Parentheses and divide by 2x plus 3. So du over 2x plus 3 equals dx. We have everything we would need. We have dx, we have u, plug it all back in. Keep in mind, this is all my u. That 2x plus 3 is still there. This is all gone now. That's this. And then look what happens. Cancel, cancel. The integral of u to the 4th du. That's a u to the 4th. You could believe me. integrate that. Remember, that's a basic power rule. So add 1 to the power, divide by your new power. So you're going to get u to the 5th over 5, new power, plus c. And then don't forget to plug your u back in. So my u is x squared plus 3. So x squared plus 3x to the 5th over 5 plus c. Okay, we already had one weird one. Let's look at the next type of weird one. So this one right here. Let's say we're doing this. So already notice it's not linear, so it's not a reverse chain rule. I can't do it. I have to do u sub. So my u would be that. Take the derivative of both sides, du over dx. Get dx by itself. Now, kind of similar to last time, look how when we plug it back in, right? I have a dx on my u. I plug everything back in, I'm going to get this. Oh man, that s is bad. U to the 3rd du over 2x. Again, 2 different variables. I can't have that. You cannot solve this one with u sub. U sub's not going to work on this one. You can't do it with 2 different variables. And reverse chain rule doesn't work because it's not linear. So what's the only way to do this one? You actually could do this one. You could expand it. You actually figure out what x squared plus 1 is. x1 times x squared plus 1 times x squared plus 1. You can expand it out, get something x to the 6, blah, 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 and then just do the power rule all the way down. Not saying it's pretty, but it does work. Right, so again, that's always an option. If you forget the chain rule, like you forget the u sub, or you forget the reverse chain rule, you can always just do that way. In some cases, it's the only way that does work, like in this one. Okay, last one. Just to make sure we really got this last one. So here, right, like you have 2 on which was my inside. Again, if you're not sure, I would always try to default for the one that has a bigger power, because the hope is when you take the derivative, it's going to cancel out with the other one. So this will be my u. So my u is going to be x cubed plus 2x, right? Step 1, find our u. Step 2, take a derivative. Derivative of u is du dx, because you're taking derivative with respect to x. On this side, that's 3x squared plus 2. Right? So I have this. Now I want to get dx by itself. So easiest thing to do is multiply both sides by dx. So you get du equals 3x squared plus 2, put parentheses for my own sake, times dx. Right? The next step, you want to put parentheses because you don't want to like do some terrible algebra and put like 3x squared plus 2 dx and then subtract 3x squared. Get me upset at you. Right? Parentheses. No sloppiness. And then divide by that. So du equals 3x squared plus 2 equals dx. Again, you can skip some of these steps if you got it. If you understand this, then you just kind of go to there. You're good. Anyway, we have everything we need now, right? The whole goal is figure out your u. Once you figure out u, take the derivative and then get dx by itself. That way you can plug it in. That's what we want to do. We want to plug in u for inside. We want to plug in this for our dx. So they could all be the same variable. So if I do it, I'm going to get, let's rewrite this u to the 1/2. Square root 1/2. This is still 3x squared plus 2. Doesn't go anywhere. And instead of dx, I'm going to put this in here, right? That equals my dx. du over 3x squared plus 2. Again, these cancel. Nice. And this is all the same variable, right? Again, if they're different variables, you can do it. Now, well, actually, I'm just going to say that because you could, but IB's not going to give you one of those. You'll worry about that when you take AP Calc some point. Or calculus, I should say, in general. Right, so for this one, now we just integrate the power rule. Add 1 to the power, which is 2 over 2, and divide by a new power. So I'm going to get 3 over 2. So we have this, u to the 3/2 over 3/2. Don't forget the trick. Bottom one goes to the top. So 2u to 3/2 over 3 plus c. And then the last step, plug your u back in. So our u is this, plug it back in. And you get this. And that's u sub. for a lot of people, the hardest thing to do in calc, in integration.